Hi, everyone. So I was thinking about how to allow people to send ethers or ERC20 tokens without having to copy and paste the Ethereum address of the recipient. So I created this smart contract in order to replace Ethereum address by a username that people will have to copy and paste if they want to send Ether or ERC20 token to their friend. So the goal of this tutorial is to show how I managed to create a username as an Ethereum address to send and receive Ethers and ERC20 token. So to start, I need to open my editor. So I'm using code editor, VS Code, you can see here. So I already created a directory. So you can see that I am connected, I am in the GNS directory. So I open a terminal and just to check that I am connected in the right term. So I run the pwd, which means print the working directory. So enter, you can see that I am in the GNS directory. And if I run the ls command, you can see that this directory is empty. So we need an empty directory because we are going to create a React box, a prefab React box inside this DNS. So what's the goal of this tutorial? So I have a slide here. I'm going to explain what we are going to do in this tutorial. So first, the goal of this directory is to allow people to send ERC20 tokens or Ethers, not by using the Ethereum address, but by using a username which we will link to an Ethereum address. So the first task is to define a user structure which will contain properties like a boolean which tells if the user is registered or not, and a string which will contain the username that will be mapped to the user Ethereum address. Next, we'll define a mapping of between a string and an address. So this mapping will map a string to an address. So the string here will be the username, and the address, this address will be the user address. So next, we'll define two functions. The first one is the register function, which will allow us to register a user and define this mapping, the mapping between the username and his Ethereum address. And then we will define a function called transfer ether. A function that will allow to transfer ether from a user to another one, not by using the Ethereum address directly, but by using the string here, which represents the username. Well, so let's move on the VS Code, and I will be using the prefab React box. So I need to download here the truthful React box in our project. So to do that, I need to run npx truthful unbox React and click on run. So this command npx truthful unbox React will create a directory or a project, which contains some files and directory that will allow us to run, of course, our decentralized application. So the command defines a structure that, or a project that is ready to use, as we see, and we can edit the project in order to add more functionalities or remove functionalities that already exist. So now, as you can see, we have our project here. So we have some directories, the client directory, which contains the source file that will run in order to open, the source file, for example, this app.js directory, which contains all the logic that we need to run our to display all that we need to display in the screen. So what is most important here is the contract directory. So here in the contracts directory, we define all our smart contracts. So truthful React box comes with a ready-to-use contract, which is called simple storage, this one, which just allows to print in this storage data uint on the screen. So next we need to edit this truthful config file, this one, because we are going to use Ganache for this tutorial. So we need to add here in the network, we need to replace develop by Ganache. So for the port, we are going to use the local host. So, for the host, let's put the host here. So we're going to use the local host, which is 127.1.0.1, or you can also write local host here, local host. Right? So let's leave this 127. For the port, Ganache, this port 7545, and we also need the network ID. So for the network ID, Ganache is for 5777. And we need to tell which compiler we are going to use. So compilers, here we are going to use SOSI, and for the version, so I'm going to use the last version of Solidity. So let's put 0.8.7. This means that we need to replace this version in all pragma in the contracts, so contract directory. So this direct contract, we have some smart contract. So we need to replace the Solidity version in this contract by the version that we put in the proof-of-config directory. So let's do that. For example, here you can see that we got a warning that says source file requires different compiler version. Yes, because here we put 0.8.7 here, but here we have different versions. So let's replace it by 0.8.7. 0.8.7. So the warning just gone. And next, we also need to modify the migration solve, because as you can see, we got the same warning here. So just replace it by 0.8.7. So the warning just disappeared, but we got another warning. So this time, as we hover in the warning, then we can see that it says visibility for constructor is ignored. So just remove the visibility, the public here. And everything is just fine. Well, so next we need to install the HG, so wallet provider, in order to run to deploy our smart contract, because we are going to we using Prefor. So for that, we need to go in the client directory. So let's go in client directory and run the following command. So npm I for install, and run this. So the command is npm I at Prefor HG wallet provider. So just click on enter. This will install this package, the HG wallet provider. So once this package is installed, so we can see that the package has been installed, we need to import it here. So let's define a variable called HG wallet provider. Yes, and we require it from the client. Yes, node module directory. Yes, and at Prefor, this one, and it's called HG wallet. This one. Nice. So next, now that we install the HG wallet provider, we can deploy the smart contract. So to do that, to deploy the smart contract, we need to be in the client directory. So as you can see, we are already in the client directory here. So next, we run the following command: Prefor migrate. So we need to say which network are we going to use. So the network, as you can see here in the Prefor config, so the network is called Ganache. So Ganache, and I like to put reset at the end. So just click enter and just wait. So let's wait. So perfect. Now you can see that the smart contracts have been deployed. So we have two smart contracts here. So the migration and the simple storage smart contracts have been deployed. So next, we can check that everything is working by running the simple decentralized application that is provided by the Prefor React box. So to do that, we need to go to the client directory and run npm run start. So now there are some polls. So yes, let's click yes. Let's wait. Okay, so the program is just show you the window. So here is the decentralized application that comes with threshold. So it's a simple smart contract that displays a value, an integer, a unsigned integer that was defined in the smart contract. So if we click confirm, we should see the value 5 here. The stored value will be 5. So let's try it. Click, and as you can see, we got 5 here. Well, so next, we need to edit our smart contract, because remember, the goal here is to map a string and to define a mapping between a string which will contains the username of the user and the address which contains the user address, in order to be able to send ethers and ERC20 tokens, not by using the user address, but by using the username, or yes, the string that will be defined, that will be linked to the user address. So let's go in the contract directory, and we just need to change this simple storage. So let's rename it GNS, for example. And since we renamed this smart contract, so let's go here in the GNS smart contract and rename also the contract. So the contract name is simple storage, so let's rename it GNS. Perfect. We also need to change something in the migration directory. So this migration, the first one is for the migration contract, migration.sol contract. The second one is for the DNS.sol. So let's click on this one, and as you can see, a variable called simple storage has been defined. So we just replace it by DNS. So DNS, which will come from DNS here, DNS. So here we replace by DNS. Nice. So we also need to remove all this code here because we don't need it. And now we need to edit our smart contract. So as I said, previously here. So the first thing to do is to define a user structure which contains a bool and a string. So let's do that. So we define a structure called user which contains a bool that that say if the user is registered or not. So we call it is registered, and a string which contains the username. So user name. Perfect. So next we need to define some mapping. So the first mapping maps an address and a user, and we make it private and call it user. So this mapping will map the user address, this one, the user address, to the user structure that is defined here. So the second mapping will map a string and an address. So we make it private and call it user naming. So this mapping maps a string, which in our case is the username and the user address. So this is the most important mapping, because what we need is to link a username to the user address, Ethereum address, such that the user will be able to send ethers or ERC20 tokens, not by using not by using the Ethereum address, but by using his username. So next, we can define the first function, which is the registration function. So register, which will take as a parameter a string, username, and we make it public so that it could be called from the outside of this one, from the outside of the counter. So this register function needs to will link the username, so the username that will be provided by the user in the front end, and the user address. So let's do that. First, we need to require that, since if this is the first time a user come and want to register, so we need to check that the user didn't register yet. So to do that, we require that the user naming at username, I will explain it, not is equal to 0 address. So the 0 address. Otherwise, we just print a method that says already registered. Sorry, registered. Okay, so this mapping, so this required, this requirement is to check if the user already registered or not. So we require that the address which is linked to the username, so because the usernaming, if you remember, the usernaming is a mapping between the username, this string here, in our case is the username, and the user address, Ethereum address. So we require, since this is the first time the user would like to register, so we require that the user Ethereum address, which is linked to the username, which is provided by the user here, is equal to the zero address. So this means that there is no user registered with this username. So next, we need to require that the user name here provided by the user is not an empty string. So we don't want to link an empty string to an Ethereum address. So to prevent user from providing an empty string, we just require that this username not to be equal to the empty address. So Solidity doesn't allow to compare strings directly. So to be able to compare strings or strings, we need to use the kcat 255 function. So we need to use this function kcat 256 and convert this string to bytes, so username, and we require it not to be equal to the empty string. So for the empty string, we do the same. We the kcat function, we convert it to bytes and put the empty string here. So if not, just say check the username or username empty username is empty. No, or just no username provided. So next, since we require that first the user didn't register yet, and that the username that the user provides is not equal to the empty string, so we can register the user now. So we put the MSG, we linked the user, which is calling this function, to the username. So username, yes, equal msg.sender. So here we just link the caller, which is msd.sender. This is the Ethereum address of the caller, the user which calls this register function. So we link the username address, Ethereum address, to the username, this username that was provided by the user. Also, we need to so we also need to write this mapping, the user mapping. So for the address, so the user address, take here, this one. So the key of this mapping is the address. So in our case, the address is nothing but the caller address, so msd.sender, and the first field is the Boolean field, which say if the user is registered or not. So he is registered, we put it to true because this function allows to register a user. So we put it to true, and the next one is the username. So the username is nothing but the username that was provided here as parameter. So we put username here. Nice. So next, we need to define a function that will allow to transfer some ethers from a user, one user to another user. So I call it transfer ether. So this function, we need to provide the username, not the Ethereum address, but the username. So this username will be used to transfer Ether from the caller to the owner of this username. So we make it public, payable, because we would like to be able to send Ether. So payable. Yes. So the first thing to do is to require that the user has been registered. So to do that, we just come here, take this, copy it, but this time we require that the address that is linked to this username is not equal to the user address. This means that we already register a user to we already linked, or an address has already been linked to this username. So we need to require that there is an address in our system linked to the username that is provided in order to receive Ether. So next, we need to also require that the caller, so msd.sender, not equal to the usernaming of the receiver. So this copy, and just click check the recipient. So this requires that the sender, so the user would like to send Ether to someone else, to this one is not the user at this address. So we prevent self-transfer. So this line is to prevent, this one is to prevent self-transfer. So you cannot send Ether to yourself. You need to provide a username that is not linked to your address. So this username here should be linked to another address, which is different to the address of the caller. So next, we can now send our Ether. So to send Ether, we use the call function. So call success. So equal. So this call function needs to be called such that here we put the recipient dot call function and some parameter here. So in order to call the call function, we need to put the recipient before the call function and dot call. So in our case, the recipient is the address which is linked to the username, but we're not going to use directly the address since we just have a username here. So we are going to use exactly this username, but we know that this username has been linked to an address. So we just call the mapping between this username and his address, which means that we are going to transform this username to its corresponding address. And this is done by the user naming mapping. So the user naming at username, this one. So this variable, this variable, user naming at username, so usernaming at username. So usernaming takes a string, which is username, and returns an address. So this quantity here is an address, the address which is linked to this username. Next, we can call the call function, call, and for the value, we just put msg value, msg dot value. Nice. Here. Perfect. So this line allows us to send ether from the caller, so from msg.sender, the caller, to the address which is linked to this username. So this username. Perfect. So we require that the transfer has been successful. So success. Perfect. That's all. So next, let's define some function, getters function. So the first one is to see if the user is registered or not. Is user registered? Is user registered? So public view, and it returns a bool. So just return the user's msg.sender, because we need to know if the caller of this function has been registered yet or is registered yet. So is registered. Remember, this is registered field or property of the user mapping. Is registered is a boolean, so it will return true if the user has been registered, or false if the user has not been is not registered yet. So the other function is the get username, which allow to retrieve a username, the username from, so it returns, public view returns public view returns a string, memory. So it returns the user name, so which is linked, the username linked to the caller user address, Ethereum address. So sender dot username. Perfect. So this function just returns the username, this one, which is a string. So username here, this one, which is a string. So it returns the username which is linked to this address, the caller address, Ethereum address. msg.sender is the caller, the user which calls the get username function. Perfect. So that's it for the smart contract. That's all. Yes, that's all. So copy. Next, we can compile the smart contract and deploy it to see if everything is working fine. So just run in the client directory. Let's run the same command: create migrate network ganache reset. So click on enter and wait to see if everything is working fine. Perfect. So as you can see, everything is working fine, and even the smart contract has been renamed. So you see here we have our DNS smart contract that has been deployed successfully. So next, let's go and see if this function here is still working fine. I think it's still working fine, but we are going to change everything here. So next, we need to remove all everything in the front end directory. So let's go to client, source, and the front end is contained in the app.js. So here we can, for example, remove all this. And just to see everything is working, let's display the following message. Welcome to DNS dot. So save it, and maybe I will run again the application and just wait. So you can see that. Perfect. So confirm. Perfect. So we have welcome to DNS dot here. So everything is working fine. So next we need to go to this, and it's a little bit strange because we should get this is not simple storage, but now it's DNS. I don't know why didn't we get an error. So if I click on enter, seems like it's not the same function. Okay, so let's try it. Yes, it's the same function. It's the same project, sorry. So let's see what we get here. So yes. So let's wait. And this time we got an error. So nice. That's what I wanted to get, because since we changed the smart contract name and is confirmed, so we should get an error here. So if we don't get an error, that means something is not working fine. So we got an error here because the simple storage contract is not defined. We just rename it DNS, so we need to change everything. So line 20. So line 20, you can see it here. So at line 20, the simple storage contract is not defined. So line 20 is here. So we name it DNS, and also simple storage here at 21. This one, no, sorry, 22. This one, 22. So this 22 DNS. And now we can save it and see that everything is working fine. And if you go back here, we can see that we got another error. So this time at line 42, we are calling the set function or the set method. So the set function was defined in the previous version of our smart contract, but now we change the smart contract. So we don't have the set function anymore here. So here we can just remove this part because we don't need it. Let's remove it and comment this, and let's try to see. So everything is perfect. And if you go back, we got welcome to DNS. Perfect. So we can open the inspector here and see that everything is working fine. So we got some messages, but no error here. So next let's work in the front-end part. So what we need is to create a small application, decentralized application, that will show how user can send Ether or ERC20 token. So for this tutorial, I'm just showing how to send Ether from a user to another user. So I'm not going to show how to send the ERC20 token from one user to another user. So we will be sending just Ether, but the process will be the same. Once you get your contract that defines the ERC20 token, you can use exactly the same function here, or just use the transfer function in your ERC20 token contract to send your token from one user to another by using not the Ethereum address in the transfer function, but the mapping, so the username, which is mapped to the user Ethereum address. So now we will be working on the front end. So for that, I will be using the semantic UI React for styling. So we need to install semantic UI React. So if you've already done that, so just go on and install semantic UI. As you can see, just go in the site, semantic UI React, and click on Get Started. And as you can see, you need to install it through the npm command, or you can use the yarn here, yarn, and here is npm. So I'm using npm, so I just copy this line, and come in the client directory. So I'm already in the client directory and pass it. So npm install semantic UI React and semantic UI CSS. So click on Enter. This will install these packages in the node modules directory, so that we could be able to use the semantic UI. Okay. Next, once the semantic UI, so now we can see that everything has been installed. So next, we need to import semantic UI in the app.js file. So I put it here. So just import semantic UI, CSS, and semantic .mean.css. So I just got it here. So you can see that once the package has been installed, you need to call it, you need to import it like that. So just copy this line and import it in your app entry file. So this one. So we can, well, so now we can use the semantic UI functionality in our code. So the first thing to do is So the first thing to do is to create sorry. So we need to create a small form which will input field which will allow us to send Ether to another contract. But remember, we first need the user to be registered. So let's work on first on the user registration part. So to do that, we need to create some function, so it's a file which will allow to register a user. So let's go. Let's try it. So I want a form which will allow to register it. So since we are going to use semantic UI, you can see that here, if we search input, you can see that we have some input here, field, that we can use. And to use a semantic UI element, you just need to click here. For example, if you want to use this input here, you click on try it and you just get the code. So you can copy this code because this is a whole function, so a whole JS file. So you just need to copy what you need in your projects. For example, since we have our file already defined, so we just need to copy this here, input, and it will describe the input in our in the front-end page. So let's go next. So how to define the input for registration? So for that, we need first to so we are going to register. Sorry. Okay, so let's start. First, I need to register. Yes. So for that, welcome. Let's put a H3 here, for example, just to say let's send. Sorry, no, not send. First, we need to register. So yes, we need to register first. So let's put register to BNS. So since we would like to have two pages, but in one, so the first one is the page which will display the form or the inputs where user can register, and the second one will be the one which will allow people or users to send Ether. So one for registration and the other for sending Ether. So to do that, we need to define a function, a variable here in state. So we can remove the storage here in state. So let's do it like that. And now we can define a string called username. So let's define a string called username. This string will contain will contain, sorry, the username of the user, which is interacting with the decentralized application. So in the component did mount, we need to get this username. So when we run the contract for the first time, so in the decentralized application, we need to get this the username and check if it is an empty string or not. So if this username is an empty string, which this means that the user has not been registered. But if it is not an empty string, it means that the user has been registered. So we need to call this function. This function is user registered to see, to know if a user has been registered or not. And this will allow us to get the username. So perfect. So how to do that? We need to go to the run example here, and we can now, because we need the account and the contract variable. So let's register. Let's define a variable called registered. So let's registered is equal to await. So since we already have a variable called contract, so which contains the contract instance. Remember, we have it here. So we call contract here. Contract, which is nothing but this, we put it instance, so we can write contract here, contract, and we move instance. So this contract is nothing but the contract that has been defined here, which contains the contract instance. So new web3.eth contract, which is the function which defines the contract through the web3 package. So here we call contract, so we can call all the methods that has been defined to this contract. So to do that, we call methods, and we call this function here registered. And since it is a view function, we just need a call here. So dot call from account. So the account, remember the account here is nothing but the account. Oh, sorry, we need to define this account here. So to define this account, what we can do is to define it here. So here we can write just after this one, account equal account 0. So the first account in this array, because web3.get accounts returns an array. So the first element of this array is nothing but the account of the current user, the user which is connected. The account with which the user is connected to web3 or to make that. So next, and here we need account but not accounts. So I also need here account, not account, account. Perfect. So next, so we come here, so we call registered. So this variable contains either true if the user has been registered, or not, or false if the user has not been registered. And now we can call, we define a username, a variable called username, this time which contains exactly the same contract that method sorry, dot method. Sorry, wait, it's not it. What we want to get the yes, get username here. So get username. So contract dot method dot get username to get the username, and also this is a view function. So we just need this call, not the send, but the call function here. Perfect. So next we need to write this in the state. So the register and the username. So do we have registered here? Not. So let's register and put it to false, for example. Perfect. So now we have every time we connect to the decentralized application, the application will call these two functions, is registered or get username, and store this variable to the state parameter. So now that we have the username, we can check here. We can check if the user is registered or not. So first we remove this, and now we would like to check if the username is registered. Then we show the transfer form, the form which will allow the user to transfer Ether. And if the user is not registered, we will show a form or some inputs which will allow the user to register. So we can also remove this one, and this time. So let's check if this dot state dot username is not equal to the empty address. So if the user is already registered, so in that case, we will write something. So here, let's write just log already registered, and if not, just console.log not registered. So this is just to show that we have a if function. So if the user has not been registered yet, so is registered. So if the user is registered, so we put already registered, else not registered. So what do we need? What we want to do here is to show the username if the user is registered. So if the user is registered, we will show the username here. So to do that, so let's keep it for now. We will come back later. So next we would like to we define a div, let's say a welcome, welcome, we put the username. So to say welcome username, this dot state dot username, and let's also define in H3 to say let's send let's send some ether using the recipient username. Perfect. So let's try to see if everything is working fine. So we don't have username at line 14 here. 14 here. We don't have username. So yes, we put it to empty string. So now everything is working fine. So let's go back and we can see that we have this. Let's send some ether using the recipient and the welcome message. Perfect. So we have the welcome message, but here, remember, we write welcome, loading here, welcome username. So username here. So welcome username, but here we just have welcome. This is because this user has not been registered yet. So this parameter here, the username in the state parameter, is an empty string. That's why we see nothing here, but we can see that there is a space here which represents an empty string. Perfect. So welcome, and let's send some ether. Just working fine. Next, let's maybe I will put a divider here. So after the H3, H2 is maybe too big. I will put it H3, and let's put some break here, and let's write a divider. So you can go in Semantic UI and click search for divider, and you can see that what a divider allows to write a line, a horizontal line here. So I'm going to use this divider. So if you want to use a simple divider, this line, for example, so let's try this one. Just click write divider. So import it from Semantic UI and just write where you would like to put your divider. Just write divider like this. So let's go back here and import. So let's import divider from Semantic UI React, this one. Perfect. And now we can come here. We can come here. So below the break, and just write divider. This divider. And if we save the project, we see that, let's wait to see if, so nice, everything is working fine. And let's go back to our project here. And as you can see, we have this horizontal line, just as we wanted. Perfect. So next, I would like to put some padding here, so some margin here before the welcome here. So to do that, I'm going to put everything in a div here. So after this, I just write another div here, div, and I will put all this in this div, like this, and write a style. So I call it either name, and I want to define the style here in this. So just open the app CSS here, and now let's write the app header. So it's the app name, sorry, the app name, this one, app, sorry, it's, the name is either name, so either name, not app name, either name, and let's put some margin, sorry, no, I'm not going to define. So in order to make some space here, we can use the app selector here. So we put some margin to the app. So this is the app, it has been centered, and we just put some margin here, margin top, and let's say 20 pixels. So if we go back, you can see that this time we have some space here. So next, let's define this content here. So now we are dealing with, we say that everything is contained in the header name, so we'll be editing this header name, sorry, this header name later. So next, let's write the first part, so which is where if the user is connected or not. So for that, we can put everything in this here, and let's call it class name, send it. So this part will allow to send ether. So to send ether or to register. So the first thing to do is to check if the user is registered or not. This dot state dot register. Remember, we define this register parameter here, which tells if the user is registered or not. So this dot set register. So if the user is registered, we do something here. If not, we do something else here. So let's start. So if the user is registered here, if the user is registered, we do something here. So what are we here? We also need to do something. So do something. So if the user is registered, we want to show a form which will allow the user to send some ether. So let's write everything in a div. So let's say we define a div. Sorry, yes. Yes. So we define this div and we name it. The class name is let's say register. Perfect. So now let's write a h2 to say send ether to, so send ether to your contact or to your friend. Let's say friend. Else, so for the other, this one, we can also take the same thing. So we put a div here, a div, and just say register to DNS. So let's check what we got. So if you go back, we can see that we got this message, register to DNS. Why? Because this user, the first user, I believe, yes, the first account has not been registered yet. So we just got this message. So if the user is registered, we got this message, send ether to your friend. But if the user is not registered, we got this message, register to DNS. So since in our case the user has not been registered yet, so we get registered to DNS. This one, register to DNS. Perfect. So we want to style this because let's style it. So the class name will be the same. So let's register and let's style this register here. So dot register. We would like the width to be 30%. So we would like the form to occupy just 30% of the screen. So we don't want the form to go from this point here to this point here. No, we just want the form to be occupying 30% of the screen. So for that, we need to write, so we register. So for that, we need the width to be 30%. We also need a mean width. So the mean width to be 300 pixels. And a max width, let's define a max width to 315. So 350 pixels, sorry. And we also need a margin left to be auto. Also margin right to be auto. So let's see what we get. Okay, everything is working perfect. So we probably don't see it here. And what we need is to style this so that we get something more style. So it is H2. Sorry, it's H2 here. We need H2. Yes. Let's see if perfect. So here we got a more bigger text. So next, let's work on register, the register part, this one. So let's put a break, sorry. Let's put a break here, which will put some space between the register and the next block. So what we need in this page, what we need is to display some input here, which will contain the username. So because we want to register a user, we need to tell to send to the smart contract the username. So for that, we are going to use the input field. So semantic, as I said, we can search for input, click, and we have a lot of examples that we can use. So just go and try it. You can see that in order to put an input, you can just write input placeholder and take this portion code and put it in your code. And in our case, we are going to use the semantic. So just write input. You need first to import the input here. So input. So next, we need the input here. So you can see that now we have input here as an error coming from, we don't have it here, but from semantic. So let's take this. So we need this input, and there are some properties. So if you want to see properties of this input, you can come here to props and click, and you will see that there are a lot of properties that allow you to style your input or to put some information. So if you are interested, just go and check all these properties. For example, you have on change, which allow to get the text that was tapped in the input field, sorry. Or if you want to put an icon, then you can use this icon here. So just go and check the dot. So in my case, I will say that fluid. So for example, fluid, if you see here, we have this fluid here, which take on the size, it allows the input to take on the size of its container. So since we define the container to be 30%, so the input will take all this, the size of this container, which is 30% of the parent container. So input, perfect. And I also need the size, to be large. Perfect. And I put placeholder, right, perfect. So username, and on change function that I just show you, because we would like to get this input and pass it and save it in the state variable here in state, this one. So for that we need the unchange function, the event, and just this dot set state. What we are going to put is nothing but, so we define a function, a variable called input username here. So let's say input username, and define as an empty string. Input username as an empty string. So next we come here and we put input username as the e.target.value. Target.value. Perfect. This is on chance. Perfect. That's all. And next, we need a button in order to register the user. So also you can go back to the semantic UI here, and if you click on button, search for button, you can see that you have a lot of button, and also you can see some properties, button properties, and you can, if you want to use one of these buttons, for example, if you want to use this button, just click here and you can see how to use it. So it's just button, click here and button. So you first need to import the button here. So let's go back. So we are going to use button, so we need to import it here, button, and now we can use it here. So I put a small break, perfect, and now I can use my button. So button, so I need it to be free, perfect, and for the size, I need it to be large, and for the color, you can see I need it VK. So you can see here the property. So you have color. So you see color, and you have a lot of colors that have been defined. So you can choose one of these colors here. So I choose this one, VK. So color, and for the content, I put register, right? Register, and on click, the on click event. So you can see that for the button here we are in the button page. So you can also define the on click on the button. On click, yes, here we are. So it is able to define the on click event here. On click function, sorry. So event, sorry. So on click, we will define a function, this dot register. So we will define a function called register, which will be triggered when this button is called. So let's copy and see that everything is working. And if we go back here, now as you can see, we have our registration form. So the user can enter the username here and click on register in order to register this user. So registering a user means that the username that will be pressed here, that the user will enter here, will be sent to the smart contract and linked through a mapping to the user address. So this address here, user Ethereum address. Perfect. So next, let's try to get this value here. So to get this value, we can, because we define the on-click the function register that will be triggered where this button is clicked. So let's define this register. Sorry, let's define, of course, this register function here. So let's go back here and define a register function. I will define it here. So register equal async. We need it to be async because we are going to use web3 function. So we need everything to be in a way async await promise. So here we need the user account, the contract, and I also want the input username here, which comes from this dot state. Perfect. So first, since here, look at here, when the user will provide the input, this function is called, the onChange is called, and the onChange does nothing but putting the user input and in the input username parameter. or variable, which is in the state variable. So let's check that when we call this function, so when user click on the button, we can get exactly this value here. So for that, let's just come here and console.log username, and it needs to be this username here, this one, which was registered input username, which is registered here. So when click, then this when user input a username, then it will be registered in this variable here in state. So now when we will click on button, clicking on button will call this register function, and this register function now does nothing but printing this on the console, of course, this username, this one, which comes from this dot state. So let's try it. So let's go. So it's saying that account, and here we have some warnings. It's not so important, but the account and the contract has not been used. So we can just remove these two. And when we click again, we get no warning. And if we go back, so now let's look at here. If we put, for example, some say and click on register. So let's look at the console here. So register, and we get username something. So username something. So let's do it again to see that the username changes. So let's click something, click register, and you get username something. This means that now when the user click on register, this username, the username that the user has provided, is now in the input username parameter variable. So we can use it in this function. For example, if we want to register to send this username in the smart contract, then we just want to use this parameter here, because as we see here, the user, the input, the username that was given by the user is now ready to use in this function, the register function. So we can use it, for example, to send the username in the contract. So next, let's register. Since we have our username, we can evaluate. So since the username is now available, we can use it to register the user. So to register a user, remember, we need to call the register function here. So register function, what is it? This one. Register function need to take a username as a parameter. So we saw that we already have this username available, so we can pass it in this register function. So let's call this function to register the user. To do that, just remove this, and I call await contract. So now I need the contract, and I also need the account. Perfect. So I need contract method that register. So the function is called register. So I need this function. I'm calling this function. So just call it, but with a parameter. So this input parameter is nothing but this one, input user. Perfect. And it's a, so by calling this function, we are going to alter the state variables, our state variables, because as you can see, we are changing the state. For example, the username, we are going to map the username and the Ethereum address. So we need to pay some Ether to call this function. So it's not a call like as we do it. We did it here, so equal, but this time it's a send function. So we need to send some Ether or to pay gases. So from who is going to pay, but the account, this account, the user which is calling this function. Perfect. So now that we call this user, we can check next. We check the register, this one, and this one, register, to check if the user has been registered. So we call this function again here, just to check that if the user has been registered. And also, we would like to get the username from the contract. So to get the username from the contract, let's define a username from contract and await contract dot method. And to get the username from the contract, we need to call the get username, this one, copy, get username. Perfect. So it's just a view function as we see here. So we don't need to pay for that. So no call function, but just send function. So no send function, but just a call function. Call. So just this line here. Perfect. So let's save it. Register is shiny. Okay. So now we can save this variable. So this variable has been defined as when the smart contract, sorry, when the decentralized application started here on component did mount. So we call this function, this one example, and this one example define the register to see a variables which check if the user has been is registered or not, and also the username. But now, when we register the user, we need to check again this variable here. So we need to get them from the smart contract to modify the state of the state parameters here. So the state variable. So now we are going to put them here. So next we need to this dot set state and register to check if the user has been registered. In our case, it should be here. And for the username, we put this username from the contract here. Perfect. Perfect. And I can put this. Perfect. So now, if we click on save, everything is fine. So we got no error here. And we can go and check that everything is working fine. So remember, if the user is registered, already registered, so here, so if the user is registered, the message, we just put send Ether to your friend from now. But if the user is not registered, then we have the form that the user must fill and register. So let's try it here. Now this user is not registered, the first user. So let's register. So for the username, I will put some say and click on register. And now we see we are interacting with the our smart contract. So we need to pay some fee in order to register the user. So just click on confirm. And now you see that the message changes. So now this user, the first user, this one, can send Ether because now he has been registered. So you can also see this message here, already registered. Perfect. Perfect. So the smart contract is working just fine. Next, we want to be able, when we change the account here, for example, now, if we go to the account 2, for example, the account 2, nothing changed, but the account 2 is not registered, but we still having sent Ether to your friend. In order to get the form, because the user is not registered, we need to reload the page here. If we reload, then we get the correct page here. So we don't need that. We don't need the user to reload or to refresh, the page in order to get this. We need the user, when clicking on other users, for example, when clicking here to user 1, we need to go back to the send Ether page, because this user is already registered. You see, already registered, but we still getting this page, which is not so interesting. So in order to get the correct page, we need to reload the page here and get sent Ether. So we don't need this behavior. So to do that, let's create a new function which is called getAccount. So I call it getAccount just after before register. So I call it getAccount. Yes, in a sync function, and now what we do is to check if this dot state, or let's do that like constant. Let's say web3 equal this dot state. Remember, we just put web3 in state variable here, web3, so we register it here, web3. So we just take our web3 variable and check if web3 is not equal null and web3 is not, or web3 is not equal undefined. So if this is the case, then we call one of the MetaMask function, which is called window.ethereum. This one, await window.ethereum, which inject a web3 object ethereum. So we trigger on event, and the event is on account change. So account changed. So this is a MetaMask functionality. So window, yes. Await window, yes, window.ethereum on, yes, of course, it is. So on account change, we are going to call this function with account. So we call this dot, sorry, if the web3 is not equal null or web3 not equal undefined, so we this one now. Why do we have Windows expect? Sorry, I got so not wait but await. Perfect. So what we are going to do is to define the same variable, the register, to check if the user is put it on false, and we also define the username, and check if the contract. So let's also take the contract from here. Contract. So if contract is not null, if the contract is not null, then we call register. So this exactly is user register, this one. So we call this here is equal this one. Perfect. So this word await, perfect. And we also call the username to be this username here. So this copy, and we also need the account here. So we don't need to get, if we get this account from here, it will always be the account, the first account. For example, if I'm connected to this account, it will be this account, but if I change, like this, if I change, it will be the same account. So in order to get exactly the account, this one account, when we change the account, to get exactly the account that we are connected with, we need to get this account from here. So here it's account 0. Perfect. So this means that when changing the account, what we are, get a call from this one, okay, and also here call from accounts this one. So here we are, if we change the account, this account 0 will be exactly the, if we change the account, this account 0 will be exactly the account to which we are connected. So next, we just need to register. So this dot set state and register so change this state variable, because we define them when changing the account. So by changing the account, on account change, we also change the state variables, register and the username. So next, we can come here, and so this one, not this one, but this one, and here we can also write this dot set state, and this time just put in account, just put account 0. So every time that the user that will change the account on account change, we put the user connected account, so the account 0 here, to the account variable state variable, this one, account. So let's try it. Sorry, so at line 68 is fine, so we don't have this function here. So if contract Okay, so let's save. We've been, so let's run it again. Yes. So we have some, let's wait. Now everything is fine. So everything is fine. And let's account is assigned, but online 63. So account, we don't need this account because we are working with the account 0 here. So we don't need account. So now if we click, you can see that everything is fine now. And now if we go back, we see that this time the first user is registered, has been registered, this first user. So we are connected to the decentralized application with this account, so the first user account, and this user has been registered. So we see that we get the message send ether, because since the user is registered, he can now send ether. But if we go to account 2, if we change account, now we see that we're still getting the same problem here. So we could not display the phone. Why? But this because we need to call this function somewhere. So this get account function. So we need to call it just in the run function here. I will call it here. So await this dot get account. This, save it, and I also need to call it on the component did mount here. So just after, let's say before catch error, so just here, I call this, yeah. So this dot get account, save it. So it's perfect. So now let's go back, and you can see that we get exactly the registration file. So if we go back to account 1, now perfect, everything is working fine. So we get this message here, but if you go to account 2, we got this. And also let's register, for example, this account. So let's put grammar and register, and once register, we go back. So because the user has been registered, we got this message here. So send ether, because the user can now send ether. And if we change the account, so account 3, which is not registered yet, we go back to the registration form. So next, let's go to, let's write this page. Let's edit the send ether page. So this is the first part. Remember, so here we say that if the user is registered, this time we just getting this, we just output this H2 message here. So what we need is to put some form and allow the user to register, to send some ether, right? So let's do that. So send it to your friends. I will put a break here. And next, I need the input, right? Because the user needs to put an amount that he wants to send and the username, or the address, but in our case the username of the recipient. So let's put input. As you can see, we already have input here because we already import input here from Semantic UI. So input, like this, like this, and we want it to be fluid. for the size, it's large, and the placeholder, so let's say the amount the user would like to send. And what is interesting is that we can write like this, input, this one, perfect. And here we can put, you can check all this from Semantic webpage. So we need a value to be, this dot state dot amount. So we define an amount in our state variable. So let's go and define the amount here. The amount. Since Web3, we could have put 0 here, but Web3 actually works with a string. So if you want to send ether, you need to provide the value as a string. So we just put empty string here. Sorry. Perfect. So so here, I think yes, the amount. And next, now that we have the amount, we can trigger the unchange. So unchange to save the amount that the user just provide, this dot set state. So the amount to e dot target dot value. Perfect. Next, this is input. So input. Perfect. So next, we also need so if we save and let's go here, we can see that we have our form, so the amount that we would like to send, and we also need another field that will where inside which we put the recipient, but the recipient will be the username, not the address, but the username of the recipient. So let's go here. I will put a break here after input. Let's put a break and another input. So input, perfect. So I want it to be fluid as usual. Size large, and the color teal. Sorry, this is the bottom. I'm writing the bottom. Sorry. So input fluid, size large, not color, but placeholder. So placeholder, username. So we have input perfect input, no, this one, and here we put input not this one, but like this, input, perfect. So the value is nothing but this dot state dot recipient. So we need to define a recipient, which we default as an empty string. So recipient here, you can put amount and recipient empty string here. So recipient here, and next we need the onChange. This one, onChange, copy, I'll pass it here, and here we put recipient. Perfect. So let's click on save and let's go back. Perfect. So now we have two input fields. So the first one is the amount, the input for the amount. So the user needs to put the amount here. And the second one is for the username. So we will be using this username to send Ether. So if we want to send Ether to the first user, now we are connected to the first user. Yes. So to the second user, his username is Glanod. So if we want to send 100 Ether to this user, so just click on Glanod here, which is his new username, and there will be a button here that we are going to define sooner. And when click on this button, then this 100 Ether will be sent to this Glanod address, username. Ethereum address to this user. Sorry. Perfect. So next, we need to define our button. The Ethereum button. So let's do that. For the button, just copy the button here. So we already have the button here, Semantic UI. So let's go back to register here. So amount, and just after input, right? Let's put some break here, and a button. So a button. So this time it's a fluid button, and for the size, the same. Let's put large. For the color, I put teal, and for the content, I just put sand, and the on click. So we will be defining a function called send it. Perfect. So let's define this function, send it here. So just after register, this one. So it's in a sync function. So let's just see if we can get exactly the amount and the username. So for that, since we put these variables in the state variable, so we need the amount and the recipient. So let's come here and we can define constant. So amount and recipient from this dot state, and let's console log them. Console log the amount and the recipient. So now let's console log these two. So there's no error. So if you go back here and enter, for example, 100 and something, click on something, yes, click on send. So we got 100 and something. So we got this variable here. Perfect. So the color is why we still getting this. It's not so sorry. Let's change the color. So the color is just to see the color name is still, so the color button color, it's not color but color. Perfect. So if I click save again and go back, and now we got a nice color. So perfect. So now if we go to, for example, user free, which is not registered, user 2, which is registered, so we have the same form. But if we go to user free, which is not registered, so the form changes. Perfect. So what next? Next, let's edit this function. So let's send ether. So the send ether here. So we can remove this. And now what we want to do is to send ether. So we would like to get the amount. We already have the amount and the recipient. We also need the Web3, the account, and the contract. Perfect. So the first thing to do is to transform, to convert the amount that the user entered from the user. Sorry. Okay. Since all amounts that are managed by Solidity need to be converted in a way. So we need to convert in a way. Sorry, we need to convert the amount that the user entered in the form to way. So to do that, let's define a ether value, which is nothing but web3 dot dot. We need to convert this value to way. So we call the two-way function from web3 library. So what we want to convert the amount dot to string. So we just making sure that it is first converted to string, because the web3 function just accepts two variables, so strings and big number. So be sure that the variables that, or the value that you enter here is a string. So that's why we force it to be a string, even if it is already a string, because when we get variables from a field, it's a string. But we force it to be a string here. Next, let's receipt. Okay, we don't need the receipt. So now that we have this value, we can call this function, the transfer ether, right? So to call this function, we need to provide the username. So the username is here, recipient. Remember, when we register or store the value, this value. So sending the ether is here. So we register this username when entering here. The username has been registered to, has been saved to it not value, so input user. sorry, recipient. Sorry, where is the recipient? Here, so we save it in the recipient here. So the recipient contains the username, the user username here. This username entered here has been stored in the recipient. So we can come here, and now let's call the transfer ether function that is defined in the smart contract in order to send ether to a friend, for example, to someone else, to another user, not using his address but just his username. So let's call this function. So to call it, let's call await contract dot method transfer. So this one, transfer ether. This transfer ether, and we need to provide the username. Or remember, the username is nothing but the recipient here. We save it in the recipient. Recipient. So this recipient is the same value as the value is the value of the name that you enter here, the string that you put here will be stored in the recipient. So we pass it here, our recipient. And then next, this is this will modify set variables, or it's a payable function. So we need to send ether, send from account. So this account. Perfect. That's all, I think. No, but we also need to provide the amount of ether that we going to send. So we need the value field here, and which is which amount of ether do we want to send? But the amount of ether is nothing but the ether value. Remember, the ether value is just this amount here, this amount that was stored in amount. So this one that we converted to weight, because Solidity just works with weight. So we need to convert this amount to weight. So this is the amount of ether to convert it in weight. So we need to take this value here and put. Perfect. Nice. So next, we need to save some this dot set state. So the amount, we put it to string empty string, and this also to empty string. Recipient empty string. Sorry. This is just to clear. Remember, we put amount and recipient as value here. As value, we put amount and recipient. So by putting them back to empty string, so it will allow to clear this value. Once we click on send, then it will clear this value here. Perfect. So now we can save and check it. So let's check if our smart contract is working fine. So I will open this. So now we have two accounts. So the account one, we can send ether because it is already registered, and account two, which is also registered, so we can send account ether, but account 3 is not registered, so it needs to be registered first. So let's Okay, first let's try to put the username here, the username, just on the right corner here. So to do that, we need to go here, and remember we have this part here, this one, username, right? So if the user is not registered, we put a is not registered. Sorry, yes. If the username is not empty, this means that if the user is registered. So if username is not empty, an empty string, if the username is an empty string, this means that the user is not registered. But if the user is registered, this cannot be an empty string. Because remember, when registering, we require that a user cannot register with an empty string. So if the user name is not an empty string, this means that if the user is registered, then we would like to do something. So let's many items. So I just want to label with size big and color purple, and I want it to be horizontal, and I want to put here something like this dot state dot username. So this comes from these two, menu and label, comes from Semantic UI. So we need to import them, menu and label here, menu and label. You see, because it knows that Semantic UI have something called menu and another thing called label, then it imports them automatically. So perfect. So now else, sorry, so here. So else, we just need to put an empty string. So if else, we put nothing, just an empty string. Perfect. We need else function here. So else, we just put an empty string. Perfect. So if we click on save and go back here, we can see that now we have the username, and because this is the first, so this is the first user that was registered, so his name is nothing but something, and the second, remember, the second user that we registered, his username was Glanold. So if we go to 2, we can see that now we get Glanold, and the username is displayed here. So Glanold, and also here we count something. Perfect. But if we change if we go to user 3, which is not registered, then we got nothing here. Welcome, just welcome, because this user is not registered. So I would like to put all this, the username to be displayed here on the right side. So for that, I need, here, I need this div. So which one? This div. So it's this one, I think this one. So I need to put it here. So this div probably here. Perfect. Okay, if I save, everything is fine. So I need to put the username, this username, this here on the right corner here. So to do that, so we have a class named ethereum. So ethereum, let's go and define the ethereum here. Dot ethereum. And let's say that the text align is nothing but white. And I also want some margin right to be 10 pixels. So click on save and let's go back. Perfect. So here we can see that now the username is displayed here on the right corner. So if we go back to the second user, look at here. So the second user, it changes, Glanol. If we go back to the first user, Simer, and if something, and if you go to account 3, nothing, because this account still needs to be registered, or to register, sorry. Perfect. Now let's check if we can send Ether using the username, which is the main point of this tutorial. So now let's go back to account 1. So account 1, and here I'm connected to account 2. It is the same account. Look, account 2, 09F0, 09F0, 100 Ether, 100 Ether. So it's exactly the same account, but here I'm using a Brave, and here I'm using Chrome. I'm using Chrome, sorry. So I'm going to account 1, and now let's send some Ether. So the account 1 has 81 Ether. So let's send 81 Ether to account 2, which has 100. You can see it here, but we can also see it here. 100 Ether. So account 2 has 100 Ether. So the account 1, which has 81 Ether. So let's send 81 Ether. So let's remember, account 2, let's go to account 2, and his username is Glanod, this one, Glanod, this, Glanod, here, Glanod. So we are going to send some Ether to this account, the account 2, but by using his username. So let's go back to account 1, and remember, the account 1 has 81 Ether. We are going to send all these 81 Ether to this account 2. So I put 81 Ether, where to send the recipient is nothing but the username. I'm going to send to Glanold. So I'm going to send 81 Ether to Glanold. So let's click on send. And now you can see we are sending 81 Ether. So let's confirm. Confirm. Perfect. So now let's refresh this page. We expect perfect 181 Ether. And if you click on here, you can see that we have 0 Ether here from the account 1. So the account 1 has just sent 81 Ether to the second account by using not the Ethereum address directly, but by using the username of the second account. And we can see that the transfer has been successful. So let's play with our decentralized application. Let's go to account 2, and let's see. This time I will go to account 1, which has 0, and we know that the username of the account 1 is something. So let's go to account 2, and check that the account 2 has 181 Ether. So I'm going to send 81 Ether to the account 1. So I'm going to send 81 Ether to account 1. But what is the username of the account 1? It is some say. So just click on send, confirm, and look at here. 81. I don't even need to refresh the page. It's updated automatically. So 81 Ether. And if we see here, then the account 2 now has just 100 because it just sent 81. And you can see here from the transaction list here that this account just sent 81 Ether. Perfect. So everything is working fine, and we can go to account 3, which is not registered, and register. So this time I will say Sam Glanold et Tumu, and register. When clicking on confirm, then we get Glanold et Tumu here. Perfect. And so let's check. Glanold et Tumu has 30 Ether. So I'm going to send him 70 Ether so that his balance will be 100 Ether. So let's go, for example, to the account 2, which has 100 Ether, and send 17 Ether to account 3. So let's go back to account 3 here, account 3, which has 30 Ether, and we are going to send him 70 Ether. So 70 Ether, which is the username here. So the username is Glanold et Tumu, I believe. So we're going to send 70 Ether to this user, to Glanold et Tumu, which has now 30 Ether. So when click on send and click confirm, so now 100, let's wait, just wait. We can see. So now you can see that now he's got 100 Ether, and this account, the balance goes from 100 Ether to 30 Ether. So he just transfer 70 Ether to this user, and his balance now become 100 Ether. So everything is working fine. We just created a smart contract that allows to map an Ethereum address with a username, so that users can use this mapping, or the username mapped to the Ethereum address to send and receive Ether. And we have created a decentralized application. So this application here, which as we see is working just fine, and which allow to simulate the behavior that has been programmed in the smart contract. So it allows to enter here, for example, we enter the amount that we want to send to a user, and instead of putting the user address, we just enter the username, the username of the user here. And when we click on send, it does exactly the same as if we provide the the Ethereum address here. So the amount will be sent to the address, the Ethereum address, which is linked to this username. So next point to check, the last one, is to see if we can register a user with a username which is already registered. For example, we know that something is already taken. So if another user would like to register with this username, something, just click on register, and we see that we got an exception, so an error. We could not register a user with a username which is already taken by another user. So this is very important because we need this to prevent conflict between users. Because if we have two users with the username and someone would like to send a ether to this username, so to which username, to which user this amount will go. So we could not solve this problem easily. So to solve this problem, to avoid this to happen, then you can see that in the smart contract, we require, when creating the smart contract somewhere here in register, we require that the user, there is no address related to this username, so the username that is provided. So we require that the username be unique. So we need the username to be unique in our system. So if the username is already registered, then we could not be able, as we see here, to register another address or another user with the same username. And you can see that if we just change the name and put some say 1, for example, and click on register, so now we get something. So now the error or the exception disappears. So now, because this name is not taken, then we can register a user with this name. So I will stop here, and as you see, everything is working fine. The smart contract is a simple smart contract which allows to send and transfer ether from a user to another one using a username, not an Ethereum address. So thank you for watching.